Um, my name is Vinod Kumar. I work as an technical architect at MTC. MTC is nothing but the Microsoft Technology Center. So I give architectural solutions to our big enterprise customers as part of my day job. So that's exactly what my day job is. And I'm a little bit of a blogger, so you have my blogs. I was in SQL Server MVP before I joined Microsoft, and I did write a book. Fortunately, unfortunately, if you haven't got a hand on it, don't worry if you ask me interesting questions. If you stump me at any point on SQL Server, because that's what we're going to talk today. And if you give me answers and I see that that's like the best answer, then I do carry, I think so, 1 or 2 more books with me. So I will give it away. Okay, so that's the book that you will get, which is SQL Server Interview Questions and Answers as part of the goodie. Yeah, this is the second session that I'm doing at GITS today. The first one we did it on Windows internals. You're now here for the 3 changes in SQL Server. And then again, you can catch me if you want. If you want to look at security as an important aspect inside SQL Server, then don't forget to catch me at the third session, which is at Hall B, which is on security discovered with SQL Server 2012. So there are a few changes that have happened, and that's exactly what we'll try to talk. How many of you here are SQL Server developers? SQL developers? I know afternoon session. Being visionary is one side of the equation, but not silent. Okay, sleeping is allowed, snoring is not. So please, okay, so be cognizant of the people next to you. So how many of you work with SQL Server? Good. Now that's a better response. So let's see, which version of SQL Server do you work with? 2008? Anybody in 2000 by any chance? SQL Server 2000? Okay. Okay. So you're feeling sorry about it? You're like you're half-hearted on that. Whether should I raise my hand for this? And like nobody else is giving me a response out here. so that's part of the equation. I think so. Support for SQL has gone through. So I think so. It's high time you start moving to the next version. What's the agenda looking like? Okay. So the agenda is very clear. I have 3 concepts which I feel are worthy enough to talk about, but they are not being publicized heavily because they are quite internal. I think so. It's going to be a challenge for me as a speaker to actually give you this content because it's a heavy content. The content is heavier in the sense because these are concepts. There's no demo. There's hardly any demo. So let me set the stage very clear. Okay, there is hardly any demo, but the concepts are quite compelling and quite interesting because they are industry changing, and that's all the more reasons why I feel that you should have this this content. So there are 3 concepts that I talk about. If there is time, which I know that I will not have, for given all practical purposes, the team has made sure less than 40 minutes wrap up and the timeout comes out. And being very kind to the next speaker, I'll make sure that I finish it on time. And as far as Q&A is concerned, don't worry. The session can spill over to the outside, and we can still have a longer conversation if you want. Okay, so SQL is the passion that I carry. So what are the takeaways for you? The 3 concepts are around design changes that have been fundamentally done. It is done hidden. These are all hidden changes. You really don't see them outside, but unless and until you double click and go into the whole inside of SQL Server. Okay, and these are all core engine behaviors. Let me start with the first one. Okay, so the first behavior that I'm going to talk about is called. It's a lot of fun. Okay, as part of the learning. The first thing that I want to talk about is called as in disk format enhancements. Okay, so can anybody out here tell me the difference between a sector and a cluster? Is rings the sector or the cluster? What is the difference between, again, then what's a cluster? It doesn't matter. You go in chorus, it's easy, right? You can confuse me. Anybody else taking a shot at it? Sector, cluster. On hard disk. Have you heard of these terminologies? Okay, good. It's a linked part? Isn't that a cylinder?
Yeah, that's a cylinder.
How is cylinder different from a cluster?
So you have 6 platter in a disk. So each and every platter will have sectors, inner and outer like that. And every sector sectors, if you limit to the top, right, all the sectors one by one, creating a cylinder kind of.
Okay. Anybody else wants to take a shot? We'll take your answer for that, but let me give somebody else also. What is a data block? What do you mean by data block? Sector or a cluster? Cluster is a? Okay. And what is a sector? Anybody from computer science here? You don't want to raise your hand at this moment, I know. Let's understand. There are two parties over here, okay? One is when you talk about sector is the fundamental unit of storage on the hard disk, okay? A sector is nothing but a fundamental unit of storage on the hard disk given by the manufacturer. Now understand that when the manufacturer tells that, oh, you have this 1 TB, and this 1 TB has these many blocks, and each of these blocks can hold this much of data, and this is how I'm going to laying out, this is how he does it. When he does that, that's called a sector, okay? That is how you store, that is given by the hard disk vendor. A cluster, on the other side, is nothing but, it is the smallest unit of storage for a file. Now, have you gone ahead and created a null, or let's understand this, okay? Let me just go through a very simple example for you, okay? So let me get into 1 second, and I don't care which folder I'm sitting on, and let me get here, okay? So you have a size out here, okay? So I'm just going ahead and creating a new text document. I don't care about what the text document has. It's got 0 KB. Is everyone with me now, till now? Yeah? So I go ahead, open this text document that I have, and I'm going to enter a character A. Each character is a byte? Yes? Okay, so far so good. So I'm just going to go ahead and close this, save it. It is a single byte, but why is it showing 1K? Yeah? It's a minimum space. Is it 1K? Is the allocation 1K? Yes or no? Okay, fine. The allocation is 1K as per you, which is not the case. Allocation is not 1K. So where was that? Yeah, you said the block size is 4K. That's the minimum allocation given by the operating system. The operating system goes ahead and says, I need a 4K. Because at the point of format, right-click format, I get a drop-down, which is the default allocation size, and then I have 5 and 2, 4 MB, so on and so forth. Each of these are different allocations that I can give. Okay? That's as per given by the hard disk, when I'm doing my OS format. But when I write it onto the disk manufacturer gives me 1. Okay? That's called as an alignment of the disk. Okay? That is 5112K. You like it or not, disks always have been 5112 till date. Till date in the sense 6 months back. Now things have changed. So what happened was, there were different operating systems that were there. So you know Windows Server 2003. Windows Server 2003 had a problem that it was never disk aligned. Windows Server 2008, Windows Vista, Windows 7, Windows Server 2008 R2, all disk aligned. When you say disk alignment, it's very simple. You might go back and say the hard disk is as 512 chunks. That's what the hardware vendor is giving me. On top of it, OS will give you an abstraction saying that, oh, you take a 4 MB, which means that you take these 8 sectors, 8, and make them as the single unit of storage for the OS. So that was the difference between the two things that you were seeing. Got it? Now, hardware vendors went ahead and did this. Okay, this is what Intel is best at doing, is to compact things. Did you ever know that Intel, the chip that you have, was never increased in size since the Pentium 4 days? The die size has been the same. And that's interesting because you're increasing the more and more horsepower on this particular chip, but not increasing the size. I could have just gone ahead and taken this laptop size chip and then said, oh, I have like a gazillion cores inside this. They went ahead and said, no, that's not what we want. We don't want to do that. Similarly, hardware vendors, you know how it was. When you, like 3 years back, you needed 1 terabyte, you got this big hard disks coming with an external power and all that. Nowadays, you get a USB powered 1 terabyte. How is it happening? They're compacting more in less. Getting it? Now, the problem of compacting more in less is this. As and when you start to compact more and more, the allocation, which is nothing but the head, which says which data is where. So just like your master boot records that you have on an OS, which is the first sector, which I allocate to understand where is my OS to go and set. Similarly, there is a sector which is allocated on the hard disk, which says, if I want to access this data, I come and ask this sector says, go there. You will find it. This sector size has never increased. So you are trying to say, earlier I used to have few MBs, then it became GBs. Now you are telling me 1 terabyte and trying to compact in this small sector size of 5 and 12. So the hardware vendors went ahead and said, oh boss, this 5 and 12 is a headache to me. Because of this 5 and 12, I have more data now. Because now to store 4 MB, I got to have 8 data points over here. So what they went ahead and said, okay, I'm not going to do the 5 and 12, I'm going to give you 4 MB. So that was the place where 5 and 12E came in. Okay, 5 and 12E is nothing but an advanced format wherein it says that each allocation sector is now going to be 4 MB. So now that means for each initialization, I just have to give this 4 MB pointer, which means that now I have in this sector, I can compact even more now. So now we'll get hard disks which are bigger and bigger. Now where is this problem coming in? The problem is here. Once you start getting this allocation mismatches, SQL Server will start to, not only SQL Server, a lot of operating systems and softwares will start to stop functioning. Because their fundamental premise in which they were developing was 5 and 12 allocations, which are hardcore allocations were 5 and 12, and they keep on assuming that. Now, why is it so critical for SQL Server? SQL Server, what is SQL Server? Let's understand that. It's a relational DB. And what is the most important property of a relational DB? Anyone? Just to wake you from your slumber. What would be the prime important thing of any relational database? What else? I know about chord rules, but it's not chord rules. Anything else comes to your mind? Asset properties? Does anyone understand asset properties? What are the asset properties? Consistency, integrity, durability. Now talk about really the last two guys. Integrity and durability. Okay? Integrity fundamentally means that I assume you're an all or nothing. You're there. I mean, you're completely written or you're not written. I take you that for granted because you are a database. That's what I assume you for. Durability means that once I write it, I assume that it is durable. That means a restart does not go ahead and hamper anything. That is the most important core tenets of any database, right? Now, these two are compromised over here. How is this done? SQL Server is assuming when I send you an 5 and 12 to write, and if the hard disk says that I've written it, it assumes that the hard disk is actually written it. Okay? Now, since SQL was developed with this 5 and 12 in mind, it just keeps on sending you in chunks of 5 and 12. So, it is quite possible in an advanced format where it is like 4 MB, I have to send you 8 chunks to make one persisted allocation on the hard disk. Till then it's not. You're getting it? Now, so SQL keeps on sending this 5 and 12, 5 and 12, and in some random time, somebody goes and says, hey, what's this power chord? It's just boom, everything is gone. Now what happens? SQL Server is assuming that I wrote 6 blocks of this 5 and 12 in this 4 MB allocation, and this is like boom, gone. Which means that you start getting data loss. That's the first myth. Second is performance, because for every write to the hard disk now has to be written as 4 MB as one single allocation, because that's what one single IO. So when you go to your set statistics IO on, set statistics time on, you get this IO, read ahead reads, all this. This will come as part of that. So in a 4 MB allocation, if I read one 4 MB sweep, it's 1 IO. The same thing in a 5 and 12, it is 8 allocation, because to get 4 MB I need 8. That's when I'll get that 4 MB. Okay, so then you'll get 8 IOs. So here, for reading one 5 and 12 MK of data, I'll have to read 4 MB, which is huge performance bottleneck, performance overhead. Okay, I've told you all this, and here is the one-line mantra. If you have understood everything, have you understood everything that I've told you? Yes? Yes, 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 yes. Best part is SQL 2012 understands advanced formatting. So you don't have to remember anything that I told you. So this is something that we didn't tell you about. Okay? SQL automatically goes ahead and identifies what your cluster is out of the box. So tell me, how do I really go and find this out? Okay? The easiest way to go ahead and find out whether you have a 5 and 12 or not is this. Okay? 1 second, let me just let me get my favorite zooming tool, and then let's get FSUtil. I don't know if you have used FSUtil any time, but FSUtil has got a very interesting part. So this is part of your sector. Okay, sector alignment is different. That's what is this. If you go today to your PCs and go ahead and run FSUtil, like what I've done here, you will not get the second one, which is called bytes per physical sector. One was the logical layering that was there, and then I said the hardware vendor is giving me something else. This is what I'm talking about, will be 4096. Okay? This is given by the OS. When I do a right click and I say format, I would have given a 4 MB cluster. That's why you were seeing when I did the right click properties, 1 byte on disk, size is 1 byte, but on disk is a different bigger number, 4K. That was this. That's what you were getting, because that's the single smallest allocation that I can give for a file. Getting it? So for this to appear in your PCs, you have to just apply a hotfix, and then you will get this. So if this is 4096, if you see bytes per physical sector is 4096, then you are on an advanced format. So far, hardware vendors are not been shipping it aggressively. I think so. This is like 1 year down the lane, you're going to see this happen. Okay. The next one that I want to just show you. So how does SQL Server know about this? It's very simple. So I'm just adding SQL Server right out here, and then don't worry about the trace flags that I'm going to use, just for the internal page structures that I'm using. As part of the allocation, and there is a file allocation that I have, which actually gives me the sector size. So when the file is created, the file goes ahead and sees what is your physical allocation, and it automatically starts to, from SQL 2012 onwards, we automatically start taking what the physical hardware vendor is giving us, rather than we allocating what the OS is giving us, because OS is fooling me. OS is not actually giving me the exact byte sector. So that's one other thing. Okay, a lot of times I've seen this is a big performance bottleneck. If you don't align your hard disk and the way in which your cluster is, you'll get performance bottlenecks in SQL Server. So because you're reading more for each allocation. Okay. So let's get a quick trivia now. So how many administrators are inside SQL Server instance? It's just a number. I'm telling how many. Just throw a number at me. Let's see how many of you guess it right. How many?
1.
Okay, that's a good start always. How many? Just some random numbers. I mean. No. Okay, you don't have to go in the same progression that he is telling. Okay, yeah. 10. Okay, it's going a double digit is better. Any guesses? I mean, more. Is it more than that? See, I know I'm a Microsoft guy, so it's not the question of yes, no, cancel. So be very careful. I'm not giving you the third choice. You just tell me what could be a random number. So let's take 10. Is 10 a right number? I don't want to give it away. So come to my security session, last but one. Okay, I'm going to give you away the answer there. Okay, so hold on to this question. There's lots on this. There's lots of hidden things inside this particular question that you will never know. If you give me some number, then I'm going to ask you what version, and then it becomes even more complicated. Then the matrix is even more fun to actually watch. So come to my last but one session where I'm going to talk about security. Okay. Now the second thing that we didn't tell you, okay, which we are telling you publicly now, is around this whole concept of VLF issues. How many understand what a VLF is? What is a VLF? Wonderful. Who said that? Okay, wonderful. So virtual log files. So you have log files, and then you have this concept called as virtual log files, which are like mini log files inside this big file. Okay. The biggest problem of virtual log files was that first you didn't have control over it. Okay, unless and until like you do a proper backup and all that. But if you have too many virtual log files, it was a performance issue. It was a well documented, undocumented feature. Because nobody wrote it anywhere. But it was well documented in minds of all administrators that if I have a lot of log files, VLFs, I have a problem. So everybody knew this, but nobody wrote anything about it. So with SQL Server 2012, we went ahead and said, okay, now this hidden gem that we have called, which is like VLF, let's make it public. Let's tell that, hey, dude, you're an administrator. Let me give you an error message saying that you have too many log files. Please go and do something about it. Okay. So we have gone ahead and made that as in public information. So here's the public information that comes in, and too many VLFs are always a problem. Okay. So I'll show you what happens. So I go to the management, I go to the logs, and then I just go ahead and view these SQL Server error logs. Okay. SQL Server error logs has got tons of information. One of the information is what I will show you is right here. You know that I've really fudged this. Okay, somehow I made a database with too many log files. So database VLF-DB has more than 1,000 virtual log files, which is excessive. Too many log files can cause long startup times, backup times. Shrinking it is advisable. Now the question here too, how many of you have seen production databases? Production databases, right? Have you ever seen that when you restart a SQL Server that it goes into some sort of an recovery mode? Have you ever seen that? Okay, so let's do that. Let's do that mimic. So as of now my databases are all fine. I'm just going to go ahead and force restart this. And when I force restart this, I'm going to give you the reason for this. Okay? So whenever you see this scenario, okay, you should know what the problem is. This will happen even in SQL Server 2008, 2008 R2, 2005 also. Okay, I don't want to talk about SQL 2000 because the way in which SQL 2000 used to work was different. So I restarted this server, and now you can see that I'm in recovery mode. Okay. Anytime you see this happening, when you restart, you're getting into an in recovery mode, and this will happen for about 3 to 4 minutes. Okay, and then it will come online. Anytime you see this, just take this in your mind. Too many VLFs. The problem. That's it. Okay, very simple. Okay, it's not documented anywhere. You're not going to get it documented anywhere. But if you go after it starts in SQL Server 2012, you go to error log, you will get this information. So if you have SCORM or something else, that will automatically go ahead and take it. Now, what is happening? Why is this happening? So this is how it is. So if I have too many VLFs, the point of restart, that means I have to reinitialize all the databases. So I have to load the MDF, I have to load the NDFs, and then the LDFs, which is log files. And then I have to go through two phases, which are called as the redo phase and an undo phase. The redo phase is nothing but since the last checkpoint or the last full backup, I have to start applying all the transactions so that I make sure that all the transactions are complete in its entirety. And then I go through what I call as in the undo phase, that is, since the last crash that happened, that you abruptly stopped SQL Server, I want to make sure as part of your asset properties, consistency, integrity, I have to make sure if anything is not rolled back or committed, has to be rolled back now. So I go through what we call as the undo phase. Now the redo and the undo phase are very much dependent on the VLFs. So it goes VLF by VLF, VLF by VLF, going and saying, are you open, are you open, are you open, are you open? If you're open, what are the logs you have taken, blah, blah, it goes on this. It does 2 times, It goes in sequence, does the redo phase, it comes back doing the undo phase. That's why this in recovery is there for a long time. The best part of, oh, okay, I think so I've just pressed escape. So the best part of this was very simple. So if I go ahead and do an FI at this moment of time, it has come online. Oh boy. Thank you. So the server has come up. Now this, when it came up, it just put one error log over there. Okay. So that was the second thing that I thought was worthy to show you. Now the third. What do we have with third? Let me just bring this down and then ask you this question. The last feature that I want to talk about. When does a checkpoint occur inside SQL Server? Do we have a control of it? I got 10 minutes more to finish. Maybe 12 minutes. And I'll finish it. Yeah? When does a checkpoint occur? Anyone wants to give it a shot? How many understand what a checkpoint is? First question. I think so I should have asked the basic question. What's a checkpoint? You save up to that particular point. That is save point. What's the checkpoint?
In equal interval, SQL Server checks whether up to this place the transaction are saved, so that when there is a restart, it will come back and check whether from that point it will discard all the transactions. Before that point, it will check whether it is there in the database.
Okay, so okay, partly right. Anything else? Anyone else wants to take a shot at it?
Committing of the uncommitted data to the database.
Okay, I'll give it to you for that. Get the goodie from me. Okay, so yeah, so partially right. Committing the uncommitted data. So what does SQL Server do? Okay, so SQL Server does, okay, when does checkpoints fire? That was what I was asking. When does checkpoint fire? Yeah. When you do some commit, does it do fire a checkpoint for you? Okay. For each commit, I cannot do a checkpoint. A write to the database cannot be forced at the point of commit. The only thing that we can force for SQL Server is for the integrity of the data, we always write to the log first. That is 100% committed. But writing to the data file is never committed. Even if you say commit, we will not go ahead and write it in the data file. We might keep it in the in-memory structure. How many attended my morning session, Windows internals? In that session, I was showing you that modified delta in between. Okay, that is exactly where it goes. So when I say commit, it goes ahead and says, okay, this is committed, I got to write it, but it is there in my log. The reason is if I restart, I can always do the redo and the undo phase, and that will take care of it. So I don't have to worry about it. So writing it to the log is the most important thing, but writing it from the memory to the data file can be some logic. Earlier it used to be different types of logics, how much of memory is in-use memory, transient memory, and then there is a background lazy writer that keeps on writing it. So there are a whole bunch of things, that heuristics that came in. There was a problem with this. Okay, since there is no science behind the way checkpoint was done, my biggest problem comes in is here. When a SQL abruptly restarts because of power failure or whatever it is, my biggest concern was I didn't know how much time it is going to take to recover now. Because I don't know when was the last time you did a full flush from the memory to this. So I have to go back to the last full backup and I have to apply all the redo and the undo phase. Remember that I was talking about. Once I start doing that, the time to get the SQL Server online was not predictable. We call it as time to recovery was never predictable. Okay, so people came back and said, hey, can you help us in finding out a better way of doing this? So here's what SQL Server went ahead and did. Okay, so we changed the algorithm. So now what we go ahead and do with respect to SQL Server is called as an indirect checkpoint. Indirect checkpoint is nothing but is a background checkpoint that runs, okay, which keeps on keeping track. See, earlier it was like a garbage collector. It used to sweep the memory and find out, oh, you're dirty, I'll keep on writing you. But I was not writing in the same order in which the transactions were happening, which meant that I had a problem. Irrespective of what was written from the memory to the disk, I had to always go back to the transaction log to go and apply the redo and the undo, because I didn't have an order to that. I didn't have an order to the madness that I was doing. So in indirect checkpoint, there is another thread which is running in parallel, which is saying, oh, you changed from 10 to 15, 15 changed from 15 to 20, I'll just keep on putting into this bucket. And then a background thread will keep on writing it. So I know in the sequence in which the transactions have happened. Since the last backup, I know when all I have written it. Since I have control completely on top of this, I really know at the point of recovery, I know from where exactly I should start my redo in the undo phase. Not from the very first, but from an intermediate space now. Okay, so I made something what we call it as an predictable thing. So here is a database that we are just creating. Okay, I just restarted my SQL server, so that's giving me that error, and I don't take a backup. So the normal behavior is, as far as the values are concerned, recovery interval is made as 0, which is the normal behavior that we have. And target recovery time in seconds is equal to 0, which means that there is no indirect checkpoint running. This feature is off by default. Okay, you have to go ahead and enable it, and there's a reason for it. Okay, I'll tell you a reason in a moment. Okay, and then let me just look at the DBID, which is DBID of 10. So I have to just make a extended event of 10, and let me just start this event on the server. And I'm going to go ahead and create a dummy file, and now I'm going to insert some values. So this is going to insert some bunch of 60,000 rows into this 10 times, so that we see so many rows are in memory, not written to the disk. Automatically some checkpoint will fire, and then it will write it, because there are too many rows as dirty on the in the memory. So it keeps on writing it. I think so it finishes around at 21 seconds. So at 21 seconds, it just about finishes. And let me check how many events were fired. Okay, there are close to about 9 rows. That means for the 10 times that I did, 9 times checkpoint has been fired internally. That means there's too many pages not written. Modify, keep on writing it. So this was firing behind the scenes. This is background checkpoint thread. Okay, now let's go to the second avatar that I'm talking about. So let me just go ahead and drop the event. I don't want to start. I'll create another database called as database 2. Now at this point in time, I'm saying that have a target recovery time of 5 minutes. This goes ahead and makes sure that irrespective of what, I'm going and giving SQL Server an SLA. I'm going to SQL Server an SLA saying that in case of a restart, I want you to make sure that it can get recovered in 300 seconds. That is, it is coming online. That is the redo and the undo phase. There is a bucket that you are creating and making sure this is well within this bucket. Okay. As soon as I do that, let me just go ahead and find out what my DBID is. DBID is 13, which is correct. Okay, and start. Use indirect checkpoint. Create a dummy file. 1 is equal to 2, and now insert it 10 times. So now, yeah, I know it's timeout. So let's insert it 10 times. So you're going to see this the same amount of rows. Now 10 times it's getting inserted. Now SQL Server is now every time that this is being written, it is finding this background thread. A bucket is being created and making sure this bucket is as small as possible so that it can get recovered in 300 seconds. And it is in the background writing it, which is called as the indirect checkpoint. Okay, I've got completed in 20 seconds. So let's go back to indirect checkpoint. Now I can see just 4 checkpoints have got fired rather than the earlier time when you had 9 checkpoints for the same amount of data. Now, what is the difference between these two? Now think about it. Earlier, everything was thrown in the air. There was a background thread that was running. You never had control over this, which meant that a background thread can come at any point in time and do a big I/O operation for you. You have no control of it. But now, with indirect checkpoint, you are saying that I'm not going to do this one sweep, but I'm constantly writing a small bit, which means that I'm having a constant I/O which I'm going to maintain. So you have a small I/O window or a small I/O that is going to be constant across for the lifetime of SQL Server. Now, if you are a very I/O hungry application, you shouldn't be using it, and that's the reason it's off by default. We'll go ahead and optimize this even more. It is very good for applications where the transactions are not hitting the ceiling of the IOPS. So you've got to be very careful around with that. Okay. So so that's what I had with respect to checkpoint. Hope you got all the three concepts: advanced files, checkpoint, and I did talk about recovery VLFs. Basics don't change. As much as I talk about all these advanced concepts, I think so the basics have remained the same. Checkpoint has been there for quite some time. It's just that the behavior has changed, but the concept of checkpoint, of writing the dirty pages, have not changed. Okay, so that's how it is. I hope you got some learning out of this this particular session, and thanks for being in silent audience. Okay, that's better now. Hope to see you in my next session on security, and there is also a session by Peenal being done over here on misconception and resolutions. There were a lot of misconceptions also that are there, which I didn't talk about, which I think so he will cover at the last session in the same hall. So thanks a lot for your time, and we'll let the next speaker take on stage. Okay, thanks.